This is Module 4, Lesson 24. We're going to start solving systems of linear equations now using elimination. Let's see. This is part of the standard that basically says that where you solve two linear equations, you find where the two of them intersect. Okay, algebraically, you can estimate it graphically. So today we're going to find solutions for a system of two linear equations using elimination. Let's see, let me add this small so I can see it. I want to review one thing really quickly here. We've talked about ways to solve a system of equations. A system of equations is when you have got two or more equations, and in our case we're going to be doing two linear equations. So it's when you've got two equations and you are looking for where the two of them intersect. This is called the solution. It will be an XY value. There are lots of ways to do it. The ways we're going to talk about doing it is by graphing and finding out where the two of them intersect. The other one is to use substitution, and we did that. Remember, we did that when we had things like y is equal to 2x plus 3 and x plus y is equal to 8, and you'd substitute this in for the y and solve. Okay, now we're going to try something called elimination. Some people find it either easier than substitution. Sometimes you can use elimination, sometimes you can't. Okay, so we're going to try this and see. Here, we've talked about systems of equations. That's where you usually have two linear equations. You've got something like a bracket or something to let you know what they are, or it tells you that you've got two linear equations. Okay, that would be a system of linear equations. It gives you the steps here on how to solve it. You can read those. My problem is, before I do something like this, if you don't see what you're doing, it doesn't make sense. So I'm going to suggest that you come back and read these steps to solve after you've done it a time or two and to see what you can do. Usually when you look at this, you go, oh, the easy way to do that is to substitute this in place of the y, or vice versa, either way. Let's see, I think usually we do the other way around, so let's just do that. The way we do it with substitution is we say, oh, let's substitute this is equal to y in here. And I would say 9x minus 23 is equal to x plus 1. And then I solve for x, okay? Well, when you do that, you'd subtract x from each side, which would give you 8x minus 23 is equal to 1. You add 23 to both sides, and you've got 8x is equal to 24. You divide both sides by 8, and x is 3, okay? And then what do? You would plug this in to find the y, because you've got the x. Remember, what you're talking about is finding the x and the y, right? You would then plug this in to find into one of these equations to find the y. Y is equal to x plus 1. Okay, you could do that. Your x is 3. Y is equal to 3 plus 1, which is 4. Y is equal to 4. Okay, so your equation, your solution is 3, 4. Okay? Now I'm going to show you how to do that using elimination. I'm going to erase this just so you can see it a little better. Now we're going to try doing it with what we call elimination. In elimination, what we're trying to do is we're trying to eliminate one of the variables. Okay? We think of it this way. We have our two equations lined up. Our y's are over our y's, our x's over our x's, the equal signs in the same place, the numbers in the same place. What if instead of adding these two equations together, and well, I am adding them together, what if I set this up so I could get rid of the y? Couldn't I do that if I multiplied everything here by -1? Okay. If you do that, you wind up with y is equal to 9x minus 23. That's what we had to start with. Plus negative 1 times y is negative y. Negative, and you put your equal sign. Negative 1 times x is negative x. Negative 1 times 1 is negative 1. Y plus negative y is 0. 9x plus negative x is 8x. Negative 23 plus negative 21 is negative 24. Okay? We're trying to solve for x. In this case, we would add 24 to both sides. And 8x is equal to 24. Divide both sides by 8. X is 3. How do we find the y if we've got the x? Remember, we're talking about a point where these two connect, right? Our x is 3. Let's find our y. Choose one of these and plug it in. This looks like my easiest one. Y is equal to x plus 1. So see, we found x. Now to find y, we just plug in our x. X is 3, so y is equal to 3 plus 1. Y is equal to 4. Our coordinates are 3, 4. You can do that either way. Now, honestly, when it says x is equal to or y is equal to, I think you're better off with substitution. So I'm not going to work these that say x is equal to or y is equal to. I'm going to get over here to number 5, where we've got them lined up, and it doesn't say x is equal to or y is equal to. When it says x is equal to or y is equal to, see how these all say y is equal to? I think substitution is probably an easier path to go. Let's look at some, though, that don't have x is equal to or y is equal to. See how it doesn't say x is equal to or y is equal to? Doesn't say x is equal to or y is equal to. Well, if it doesn't, oftentimes it's easier to use elimination. I'm trying to eliminate one of these variables. Okay? You know you're adding the two equations. I have positive x and positive x here. I have a positive y. If I say positive y plus a negative y, isn't the y going to be gone? I don't even need to multiply by anything. So x plus x is 2x. Positive y plus negative y gives you 0y, so that's gone. 7 plus 3 gives me 10. Divide both sides by 2, and x is equal to 5. So I've got my x value, it's 5. Let's find our y value. To get the y value, substitute into one of the equations. This one says x plus y is equal to 3. Let's plug our x in. 5 plus y is equal to 3. Subtract 5 from each side, and y is equal to negative 2. My coordinates are 5, negative 2. Okay? Now let's look at number 6. Okay? Remember, you're adding the two equations. Neither one of these say x is equal to or y is equal to, so I can't use substitution. That means I'm going to try to use elimination. I want to get rid of one of these variables. Make sure they're lined up. The x's are over each other, the y's are over each other, the equal signs are over each other, the numbers are over each other. Okay? Well, these aren't the same number. The 7's are, so I need to get rid of these. I have a positive 7 and a positive 7. That would give me 14x. That's not what I want. In order to get rid of this 7x, add a 7x plus a negative 7x, I need to multiply everything here by negative 1. Okay? So let's keep what's on top. 7x minus 4y equals negative 11. Negative 1 times negative 7x would give me a negative 7x. Negative 1 times negative 10y would give me a positive 10y. Negative 1 times a positive 25 is a negative 25. Okay? 7x plus negative 7x gives you 0. So this is gone. Negative 4y plus 10y would give you 6y. Negative 11 plus negative 25 would be negative 36. And to solve for y, I divide both sides by 6, and y is equal to negative 6. Now remember, we're looking for where the two lines intersect. We're looking for the x and y value. We've said y is negative 6. We need to find x, don't we? To find x, we plug this into one of these equations, just like we did when we were doing substitution. So this is how we found our y. Now we need to find our x. Use either equation, doesn't matter. 7x minus 4y equals negative 11. My y is negative 6. 7x minus 4 times negative 6 equals negative 11. 7x, negative 4 times negative 6 is positive 24. Equals negative 11. We're solving for our x. We'd subtract 24 from each side. Our 7x then would be negative 35. Divide both sides by 7. And x is equal to negative 5. Okay? Our coordinates then would be, our solution would be negative 5, negative 6. All right? Let's look at number 7. Now, none of these say x is equal to or y is equal to, does it? Notice that's what we're doing. We're checking to see, does it say x is equal to or y is equal to? No, it doesn't. Does it have all the variables over each other? The x's are over each other. The y's are over each other. Equals are over each other. The numbers are over each other. Okay? So let's try to eliminate one of these variables. Here, look, the 2's match. It's a negative 2 and a negative 2. I can't say a negative 2 plus a negative 2. That would give me a negative 4y, right? So I need to multiply all of one of these equations by negative 1, y, so I can have a negative 2 plus a positive 2. Okay, so let's bring over what's here. 4x minus 2y equals negative 30. Distributive property, negative 1 times negative x is a positive x. Negative 1 times negative 2y is a positive 2y. Remember, we're adding these. A negative 1 times a 5 is a negative 5. Notice we multiplied everything in the equation by negative 1. Everything had to change signs. My negative x is a positive x. My negative 2y is a positive 2y. My positive 5 is a negative 5. I'm adding these. 4x plus 1x, because if there's nothing there, you know it's a 1, is 5x. Negative 2y plus positive 2y is 0. This one's gone. This one, what I wanted to do was to eliminate a variable. Negative 30 plus negative 5 is negative 35. Divide both sides by 5, and x is equal to negative 7. Remember, we're looking for where two lines intersect. It's called your solution. Your x is negative 7. That's how we found our x value. Now let's find our y. To find our y, we simply substitute it into one of these equations. Doesn't matter which one. We got 4x minus 2y equals negative 30. Our x is negative 7. 4 times negative 7 minus 2y equals negative 30. 4 times negative 7 is negative 28. Minus 2y equals negative 30. Let's add 28 to both sides. Negative 2y is equal to negative 2. divide both sides by -2, and y is going to be equal to 1. Our coordinates for this point are -7, 1. Okay? And let's look at number 8 down here. Do any of these say x is equal to or y is equal to? No, it doesn't. So we're going to need to use elimination. We can't really use substitution. Let's find the coefficients that match. Here we've got them, the 2's. Now we're adding these two. 2y plus 2y would give me 4y. That's not what I want. I want to be able to have a 2y plus a -2y, right? Multiply everything down here by -1. That way I can change all the signs here. 5x plus 2y equals -25. -1, and see we're adding these. -1 times 4 is -4x. -1 times 2y is -2y. -1 times -18 is +18. See, all we did is we changed the sign on every one of these, okay? Now, let's solve for our x. That's what we're looking for, because we're about to get rid of our y. 5x plus -4x gives me 1x. 2y plus -2y gives me 0. That's gone. -25 plus 18 would give me -7. Our x is -7. Remember, we're talking about where the two lines intersect the solution. Your x is -7. How do we get to the y? I choose one of these equations and I would plug this in. Let's try this one. 5x plus 2y equals -25. This is part of that. Thank you, slide. Our x is -7. 5 times -7 plus 2y equals -25. 5 times -7 is -35. Plus 2y equals -25. Let's add 35 to each side. And I've got 2y is equal to 10. Let's divide both sides by 2, and y is equal to 5. My solution, the place where they intersect, is -7, 5. Now let's look at number 9. Do any of these say x is equal to or y is equal to? Because if they do, we could use substitution, but they don't. All right. We know we're adding the two equations. We're trying to eliminate a variable. Okay, the 4 and 7 do not match, but we know there's an understood 1 in front of each of these. Well, this is a -1. -1 plus -1 would be -2. That's not what I need. I need a +1 there. So let's multiply everything here by -1. This would give me 4x minus 1y equals -11. Multiply -1 times this, I get -7x. So remember, we're adding these. -7x. -1 times -1 is a +1y. -1 times -26 is a +26. Okay? See how all we did is change each one of the signs in front of those? And we're always adding these when we are doing elimination, so adding the equations. 4x plus -3x is -7x is -3x. -1y plus +1y gives you 0. That's gone. Equals -11 plus 26 would give me 15. Let's divide both sides by the -3 we have here. And x would be -5. Remember, we're looking for where the two lines intersect, the solution. The x value here is -5. We need to find the y value. Find the y value, whether you're substituting or using elimination, you plug it into one of these equations. So how about we start with 4x minus y equals -11. Let's plug in our x. 4 times negative 5 minus y equals negative 11. 4 times negative 5 is negative 20 minus y equals negative 11. Let's add 20 to both sides. That gives me negative y equals 9. Yes, okay? Because the difference in those would be 9. And you got a positive number here. It's the bigger absolute value. But I don't want negative y. I need it to be y. So let's divide both sides by negative 1. And y is equal to negative 9. Our coordinates are negative 5, negative 9 for the solution to this system of linear equations. Now let's try this one down here. I'm going to extend the page a little bit here so we can see it a little better. Does anything say x is equal to or y is equal to? It doesn't, so we can't really use substitution without having to rewrite them. I do have my x's over each other, my y's over each other, my equals over each other, and my numbers over each other. Okay, so if I look at it, I can either get rid of the 3's or the y's. Doesn't matter, whichever one's fine. Problem is, since you're adding them, this is a positive 3 plus a positive 3, that'd be positive 6x. That'd be positive 1y plus positive 1y is positive 2y. So I need to multiply this one here by negative 1 to change all the signs, don't I? 3x plus y equals 9. Okay, negative 1 times 3x is negative 3x. Negative 1 times y is negative y. Negative 1 times negative 4 gives you positive 4, right? This is a very interesting one. 3y plus negative 3y is 0. Positive, let's see, 1y plus negative 1y is 0. 9 plus 4 is 13. Is 0 equal to 13? No. So therefore we have no solution. Okay? Now look at our two equations. We had 3x plus y equals 9. We have 3x plus y equals negative 4. That can't happen. You can't have all of these the same and equal to two different numbers, can you? So what you have is something that has no solution. No solution means you're talking about parallel lines. Next page on this. Look at something. Yes. Okay. Now, these are, you can, it says by elimination, but I'm going to let you use whatever you want to here. If you look at these all say y is equal to, right? These you should be able to do just simply with substitution. If it says x is equal to or y is equal to, I can substitute that in place of this. 3x plus 13 equals 7x plus 17. So I've gotten rid of the y, I'm looking for the x. Let's subtract 7x from both sides. I've got negative 4x plus 13 is equal to 17. Let's subtract 13 from both sides. I have negative 4x is equal to 4. Let's divide both sides by negative 4. And x is equal to negative 1. Remember, we're talking about where these two lines intersect. Your x is negative 1. Let's find your y. And when we're finding the other variable, you just plug into one of the equations. Y is equal to 3x plus 13. If my x is negative 1, that's 3 times negative 1 plus 13. That would be negative 3 plus 13, which gives me 10. negative 1, 10, okay? My solution is negative 1, 10, okay? Both of these say y is equal to, so I can plug this in for the y, can't I? I can use substitution here. 4x minus 15 is equal to negative 2x minus 3. If you're crossing the equal sign, I'd add 2x to both sides. I would have 6x minus 15 is equal to negative 3. Okay, let's add 15 to both sides. I have 6x is equal to 12. Divide both sides by 6. And x is equal to 2. Remember, we're looking for where the two lines intersect. And your x is 2. Now, let's find your y. Choose one of the equations and plug your x in. Y is equal to 4x minus 15. Y would be equal to 4 times our 2 minus 15. 4 times 2 is 8. Minus 15 would give me y is negative 7. My coordinates are 2, negative 7. Okay, let's look at this one. Our y's, we've got a y is equal to, so we can use substitution. I'm going to substitute this in place of the y. Negative 4x plus 14 is equal to 10x minus 28. Cross the equal sign, I'm going to be subtracting 10x from both sides, which gives me negative 14x plus 14 is equal to negative 28. We subtract 14 from each side, and negative 14x is equal to negative 42. Divide both sides by negative 14, and x is equal to 3, okay? So your x is 3. Okay, let's see about your y. This says y is equal to negative 4x plus 14. Y is equal to negative 4 times 3 plus 14. Y is equal to negative 12 plus 14. Y is equal to 2. 3, 2. Okay? And then on this one, does it say x is equal to or y is equal to? It does, so I can use substitution on this one. Let's plug that in there. Negative 7x minus 29 is equal to negative 3x minus 9. Crossing that equal sign, I'm adding 3x to both sides. And I've got negative 4x minus 29 is equal to negative 9. Let's add 29 to both sides. Now I've got negative 4x is equal to 20. Divide both sides by negative 4. X is equal to negative 5. We're talking about where two lines intersect. This says the x is negative 5. Let's look for the y. Y is equal to negative 7x minus 29. Y is equal to negative 7 times negative 5 minus 29. Y is equal to negative times a negative is a positive. 35 minus 29. Y would be equal to 6. So your coordinates are negative 5, 6. Okay? Let's look down here at number 5. Does this say x is equal to or y is equal to? It does not. So we're going to have to use elimination here. We can't substitute. All right, if we're using elimination, then we need to make sure everything's lined up. Our x's are over each other, our y's are over each other, our numbers are over each other. Okay, if I add these, will I be able to get rid of any of the variables? 1x plus 1x is 2x. Negative 1y plus positive 1y will get rid of the y. So we're going to do that. X plus X is 2X. Negative 1Y plus negative Y, or plus positive Y, gives you 0. Negative 13 plus negative 5 gives you negative 18. Let's divide both sides by 2, and X is equal to negative 9. Okay, now how do we find our Y? Plug it into either equation. Plug in our X. Remember, we're looking where the two lines intersect. Our X is negative 9. Let's find our Y. I've got X minus Y equals negative 13. My X is negative 9. Negative 9 minus Y equals negative 13. Let's cross that equal sign by adding 9 to both sides. And I've got negative Y is equal to negative 4. I don't want negative Y, I need a positive Y. So you know there's an understood negative 1 there. Well, let's divide both of them by negative 1. And then Y then is equal to 4. My coordinates are negative 9, 4. That's the solution for this system of linear equations. Let's look at these. Do either one of these say X is equal to or Y is equal to? They do not do that. So I'm going to have to use elimination. That means I'm adding the two equations. Let's see if I can get rid of one of the variables. I've got 2x and 2x, but 2x plus 2x gives you 4x. And I need to get rid of one of these. What I do is I multiply this entire equation by negative 1, so I can get rid of this variable. I have a 2x plus a negative 2x. Let's rewrite it so we can see it. 2x minus 9y is equal to 17, plus negative 1 times 2x is negative 2x. Negative 1 times 3y is negative 3y. Negative 1 times negative 19 is positive 19. Okay? 2x plus negative 2x gets rid of the x. I've eliminated the x. Negative 9y plus negative 3y is negative 12y. 17 plus 19, let's see, that's a 6, that's 36. Divide both sides by negative 12, and I've got y is equal to 3. Okay, now how can I find x if I've got y? We're talking about where two lines intersect. My y is 3. I need to find my x. Plug it into either equation to find the x. Say 2x minus 9y equals 17. My y is 3, so 2x minus 9 times 3 equals 17. 2x minus 9 times 3 is 27, equals 17. Let's add 27 to both sides. 2x is equal to 17 plus 27, that's 14, that's 44. Divide both sides by 2, and x is 22. Okay? So my numbers are 22, 3. All right? On 7. None of them say x is equal to or y is equal to. All right? So I'm adding. I'm going to have to use elimination. I add the two equations. Well, if I add the two equations, 3x plus 3x would give me 9x, all right? Negative y plus negative y gives me negative 2y, correct? Okay, so I'm going to need to put a negative 1 in front of one of these so I can get rid of everything there. 3x minus y equals 7, plus negative 1 times 3x is negative 3x. Negative 1 times negative y is positive y. Negative 1 times 7 is negative 7. 3x plus negative 3x is 0. Negative 1y plus positive 1y is 0. 7 plus negative 7 is 0. So 0 is equal to 0. That means we have infinite solutions, right? Okay, now I want you to look at the two equations so we can see what we actually had to start with. Infinite solutions means we're talking about two lines that are exactly the same, right on top of each other, right? Two lines that are exactly the same, that are right on top of each other. That way, every point on there is exactly the same. Well, look at these. Isn't this exactly the same equation? 3x minus y equals 7. 3x minus y equals 7. I didn't even have to go through this. This was the same equation. It is the same line. There's infinite solutions. Okay? All right, let's look at this one. Does anything say x is equal to or y is equal to? No, so I cannot use substitution. I'm going to have to use elimination. That means I'm adding the two equations. The x are lined up, the y's are lined up, the numbers are lined up. I have the 8. Negative 8 plus a negative 8 is going to give me negative 16. So I need to multiply this down here by negative 1. Everything down here by negative 1. So I can get rid of the 8. Let's start with what's here. Negative 8x plus y is equal to 6. Negative 1 times negative 8 is a positive 8. And remember, we're adding these, okay? I don't need to put a positive in front of it. Okay? Let me just sort of erase that so you won't see it. I'm adding the 8x. Negative 1 times 3 is negative 3y. Negative 1 times negative 14 is a positive 14. Negative 8x plus 8x gives you 0. Y plus negative 3y is negative 2y is equal to 6 plus 14 is 20. Let's divide both sides by negative 2, and y is equal to negative 10. Okay, now remember, we're looking for the two where the two lines intersect. We have found that my y is negative 10. We need to find my x. Choose either equation, it doesn't matter which one. How about negative 8x plus y, and your y is negative 10, equals 6. Negative 8x, let's see, what are we going to do? Oh, change how I do that. How about we add the 10 to both sides so we get rid of that? And I now have negative 8x is equal to 16. Let's divide both sides by negative 8. And x is equal to negative 2. So we're talking about negative 2, negative 10. Let's look at number 9. I've got 2x plus y equals negative 5. 7x plus y is equal to negative 20. Nothing says x is equal to or y is equal to, so I have to use elimination. I'm adding the two equations. Well, the 2 and 7 are not the same, but there's an understood 1 in front of each of these. That would give me 1y plus 1y, which is 2y. That won't get rid of it. I've got to multiply everything here by negative 1. Okay? So I have 2x plus 1y equals negative 5. And I've got negative 1 times 7x is negative 7x. As you see, we're adding these. Negative 1 times that would give me negative 1y or negative y. Negative 1 times negative 20 is positive 20. 2x plus negative 7x is negative 5x. Y plus negative y is 0. Negative 5 plus 20 gives me 15. Let's divide both sides by negative 5. And x is negative 3. Okay? The x is negative 3. We're looking for the y. Plug it in. Let's plug it into one of these equations. Let's say 2x plus y equals negative 5. My x is negative 3. 2 times negative 3 plus y is negative 5. 2 times negative 3 is negative 6 plus y is negative 5. Add 6 to both sides. and y is equal to 1. Negative 3, 1 is our solution for that set of system of linear equations. Okay, let's look at this system of linear equations. Does anything say x is equal to or y is equal to? It does not. So I'm going to have to use elimination. That means I'm adding the equations. The x's are over each other, the y's are over each other, the equal signs are over each other, the numbers are over each other. Okay? If I say 5y plus 5y, I'm going to get 10y. So I'm going to need to multiply everything here by negative 1 so I can get rid of this y, 5y. So let's start with negative 4x plus 5y is equal to 12. Negative 1 times 2x is negative 2x. Negative 1 times 5y would be negative 5y. Negative 1 times negative 6 is positive 6. Negative 4x plus negative 2x is negative 6x. Okay. Negative 5 plus positive 5 plus negative 5y is 0. 12 plus 6 is 18. Divide both sides by negative 6, and x is equal to negative 3. Okay? Let's look at number 11. Do I have anything that says x is equal to or y is equal to there? Oh, by the way, oh, we got x. We didn't get y here, did we? Sorry about that. We need where our two lines intersect. We've got our x, which is 3. We need to get our y. To get our y, let's plug it into one of these equations. Negative 4x plus 5y equals 12. Okay. If our x is negative 3, that's negative 4 times negative 3 plus 5y equals 12. Negative 4 times negative 3 is 12 plus 5y is equal to 12. Let's subtract 12 from both sides. 5y equals 0. Divide by 5. Y equals 0. So your x is 3, your y is 0. Number 11, if I look at it, does it have x is equal to or y is equal to on either of those? No. So I've got to use elimination, which means I'm adding my two equations. My x's are over each other, my y's are over each other, my equals are over each other, my numbers are lined up, okay? If I have a negative y plus a negative y, that's going to give me a negative 2y. That's not what I need. I need to get rid of this y. So let's multiply everything here by negative 1 to change their signs. And 5x minus y equals 26. Okay? And I'm adding to it, negative 1 times 3 is negative 3x. Negative 1 times negative y is positive y. Negative 1 times 18 is negative 18. 5x plus negative 3x is 2x. Negative y plus y is 0. 26 plus negative 18 would give me 8. So yes, divide both sides by 2, and x is equal to 4. Remember, we're looking for where the two lines intersect. Our x is 4. We're looking for our y now. To get the y, let's plug into either equation. 5x minus y equals 26. That's 5 times 4 minus y is equal to 26. 20 minus y is 26. Subtract both sides by 20. Negative y is 6. That's a negative 1y. Divide both sides by negative 1, and y is equal to negative 6. Okay? So our solution would be 4, negative 6. And then let's try this one. And I'm going to ask you to step back first from it and see. 3x minus 2y is equal to 5. 3x minus 2y is equal to 16. Can 3x minus 2y equal both 5 and 16? It cannot. So there is no solution. If there's no solution, you're talking about parallel lines. If you're not sure about this, guys, realize that there's no x equal to and there's no y is equal to. I'd need to use elimination. I don't have a way to get rid of the 3x or the 2y because they're the same signs. So I'd have 3x minus 2y equals 5. Multiply everything by negative. That would give me negative 3x, positive 2y, negative 16. Negative 3x plus negative 3x is 0. Negative 2y plus 2y is 0. 5 plus negative 16 is negative 11, right? 0 is equal to negative 11. No, it's not. See, it proves to you right there there's no solution. Okay, now, in the workbook, look at page 347. Let's look at this example. If I'm dealing with this one, none of it says x is equal to or y is equal to, so I'm going to need to use elimination. My x's are over each other, my y's are over each other, my y equals are lined up, my numbers are lined up. You have a negative 5y plus a positive 5y. When you add those, that's going to be 0. So I got 6x plus 2x is 8x. Negative 5y plus 5y is 0. 21 plus negative 5 would give me 16. Divide both of those by 8, and x is 2. Remember, we're looking for where these two lines intersect. So if x is 2, let's find y. Let's plug it into either one of these. 6x minus 5y equals 21. 6 times 2 minus 5 times y is equal to 21. 12 minus 5y equals 21. Okay, let's subtract 12 from both sides. Negative 5y is equal to 9. Divide both sides by negative 5. And y would be equal to negative 9/5. 2 and negative 9/5. Okay, did I do that right? Okay. 8y, 21. Yep. Okay. What if you're looking at this one? You've got the same situation. There's no x is equal to or y is equal to, so you got to use elimination. Negative 7y plus 7y would be 0, so I've got 9x, this is gone, is equal to negative 18. Divide by 9, x is equal to negative 2. So my x is negative 2, let's find my y. 6 times negative 2 minus 7y equals negative 10. Negative 12 minus 7y is negative 10. Let's add 12 to both sides. Negative 7y is equal to 2. Divide both sides by negative 7, and y would be negative 2/7. Okay. And then the last page that I wanted to show you, workbook page 357. Again, there's nothing that says x is equal to or y is equal to. You would be adding these. I'm going to have 8x plus a negative 8x. That would get rid of that one, so you don't have to worry about it. 5y plus 1y is 6y is equal to 19 minus 1 is 18. Divide by 6. Y would be equal to 3. Okay, so when our lines cross, we're talking about the y being 3. We're looking for the x. 8x plus 5 times 3 equals 19. 8x plus 15 equals 19. I'd subtract 15 from each side. 8x would be equal to 4. Divide both sides by 8. X would be 4/8, and you can simplify that to 1/2. So my coordinates here are 1/2 and 3. And then the last one I want to show you is number 11 on that page. of the same situation. Nothing says x is equal to or y is equal to, right? What we need to do is add the two. We're going to use elimination. We'll get rid of the negative 5y plus 5y. That will get rid of that. So let's just do them. 3x plus 6x is 9x. Negative 5y plus 5y is 0. So that's gone. 17 plus 10 is 27. Divide both sides by 9. And x is 3. Okay? If x is 3, let's find our y. 3x minus 5y equals 17. And so we've got our x is 3. 3 times 3 minus 5y is 17. 3 times 3 is 9 minus 5y is 17. Let's subtract 9 from both sides. Negative 5y is equal to, let's see, 17 minus 9. 8. Okay. 17 minus 9. Hold on. Okay, so to get to our y, we divide both sides by negative 5. And y would be equal to negative 8/5. So your answers can be fractions. Your coordinates can be fractions. The solution for this one is at 3, negative 8/5.